All right, let's take a look at section 6.1, the polygon angle sum theorem. Before we do this, we need to go back and we need to look at some of these names of our different polygons. You need to know the names for each because throughout this lesson and throughout the rest of our class, we're going to be referring to these by their side links, and some of these have special names. So we won't always just refer to it by the number. We'll have a name that goes with it. So a three-sided polygon is a triangle. Four-sided, now it's not a square or rectangle, it's called a quadrilateral. Five-sided is called a pentagon. Six-sided is a hexagon. Seven-sided, this is one you probably haven't used very much or heard of, is a heptagon. Eight-sided is an octagon. The nine-sided is a nonagon. The 10-sided is a decagon. And 11 and 12 are kind of unique. This is undecagon or undecagon. One and decagon. This one's going to be dodecagon. And anything past 12 is going to be just the number and gon. So this 13 is 13 gon. So it could be 14 gon, 15 gon, 16 gon, and so on and so forth. So we have triangles, quadrilaterals, pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, dodecagon, and a 13 gon. So what I want us to look at now is I want you to sketch a convex pentagon, hexagon, and heptagon. For each figure, draw the diagonal so you can all you can from one vertex. What conjecture can you make about the number of relationships between the number of sides of a polygon and the number of triangles formed by the diagonals of one vertex? So I'll give you an idea of what we're looking for here. Then I want you to draw the rest on your own. So for the first one here, we're going to draw a pentagon. So that's going to be 5 sides. So it doesn't really matter how exactly you draw it, as long as it's got 5 sides and it doesn't go inside or outside. It's a hexagon. 1, 2, 3, 4, 5. Then I want you to pick one vertex. So we'll choose a vertex here. And I'll choose this one. I want to draw to every single vertex I can. So this is the first one. I can't draw to this one because it's already a line, one of our sides, so I can draw to this one. And so then I want you to look at the number of sides and the number of triangles that are formed. So now I want you to continue that for the hexagon and the heptagon. So pause the video now, come back and check out your answer when you're done. All right, so there are 5 sides in a pentagon, and it forms 3 triangles. Now, each triangle has a total measure of 180 degrees. This one has 180, and so does this one. So if we have 180 degrees in each triangle, we have 3 triangles. So the sum of this 5-sided polygon is going to be 3 times 180, which is going to give us, so 540 degrees is the sum of the pentagon. So if you look at the next one here, we have 1, 2, 3, 4, 5, 6 sides. And we can form 1, 2, 3, 4 triangles. And in this one here, we have 7 sides, and we can form 1, 2, 3, 4, 5 triangles. So that means that if it's 180 degrees in each triangle, and we have 4 of them, then it takes 4 times 180. That's going to give us 720 degrees. The same thing here. We have 7 sides, 5 triangles. Therefore, it's 5 times 180. That's going to give us 900 degrees. So a heptagon has a total of 900 degrees. So like a triangle has 180, a pentagon has 540. So what is the relationship? Well, if you notice here that for the number of sides, it's always 2 less triangles. 6, 4, 7, and 5. That means if we had an octagon, it would be 6 triangles. If we went down this way and had a quadrilateral, it would be 2 triangles. So 4 sides would give us 2 triangles. That would give us 360. So if you notice here, you're going up 180 degrees for every time. So we could make our prediction could be, or our conjecture would be that we are going, for every number of sides, we're going to subtract 2 and multiply that by 180. So that brings us to our first equation, the polygon angle sum theorem. The sum of the measures of the interior angles of an n-gon, which means for any sided polygon, is n minus 2 times 180. Now from here on out, we're going to use the letter n in almost all cases to represent the number of sides in a polygon. So for any sided polygon, or n-gon, it's going to be n minus 2 times 180. All right, let's look at example 1, finding the sum of a polygon angle sum theorem. So what is the sum of the interior angle measures of a decagon? Well, the first thing I want you to do is identify the number of sides. Decagon has 10. So that means I'm going to take my n minus 2 times 180, 10 minus 2 times 180. That becomes 8 times 180, and 8 times 180 is going to give us 1,440 degrees. So the sum of a decagon is going to add up to be 1,440 degrees. All right, let's look at the next one. So in part B, I want you to do both parts here. The first part says, what is the sum of the interior angle measures of a 17-gon? And the second part says, if the sum of the interior angle measures of a polygon is 1980, how can you find the number of sides of a polygon? So I want you to find the number of sides for this polygon if the angle measures sum up to be 1780. So you got 2 parts to do. So pause your video, work it out, come back and check your answer when you're done. All right, so number of sides in this polygon is 17. 17 minus 2 is 15. 15 times 180 is 2,700 degrees. Now the next one, the sum equation says the sum of the angles is equal to n minus 2 times 180. So you should have gotten 13 as your answer. So what we have to do is we're going to replace the sum 1980 for the word sum, and now we're going to solve for n. So the first thing we have to do is get rid of the 180. So we divide by 180. That cancels over here. Oops, not 1980. 180. So this is going to give us 11. So 11 is equal to n minus 2, and then we add 2. 13 is equal to n. So that's how we get our number of sides. So we take the sum, divide it by 180, and then add 2. All right, so there are 3 types of polygons we're going to look at here today. In the future, we have an equilateral, means all the sides are the same, but not necessarily all the angles. Equal angular means that all the angles are the same. but not necessarily the side lengths. And then we have the term regular. This is one we're going to use the most. The regular polygon is the one that has all angles and all sides the same. So it's equal angular and equilateral. So for a lot of these, we're going to refer to a regular polygon, not only in this chapter, but many chapters. We're going to refer to regular polygons. So regular means everything is the same. So the corollary to the polygon angle sum theorem is that the measure of each interior angle of a regular n-gon is n minus 2 times 180. It's going to be the sum divided by the number of sides. So sum of the angles divided by the number of sides is how we're going to get the measure of each interior angle of a regular polygon. This only works for a regular. So the common housefly has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon like the one shown here in white. What is the measure of each interior angle in one hexagonal facet? So first thing we need to do is we need to figure out what is our sum. Well, before we do that, we have to identify how many sides. We can see it's 6 hexagonal, 6. And so we need to find the sum, because it's the sum of our angles, n minus 2 times 180, divided by the number of sides. So we get 6 minus 2 times 180 divided by 6. So 4 times 180 divided by 6. Now since 6 can go into 18 3 times, we can add the 0 and get 30. 4 times 30 is going to give us 120 degrees. So you can also multiply 4 times 180 and then divide it by 6, and you'll still get the same answer. So that means each interior angle is going to be 120 degrees. So it's a hexagon. So if you look back at this picture here, our previous page, in this regular polygon, this is a hexagon. All angles are the same. That means each angle in here is going to be 120 degrees. So let's look at the next one. What is the measure of each interior angle of a regular nonagon? So pause the video, work it out, come back and check your answer when you're done. All right, so a nonagon, as you remember, should be its 9 sides. So we do 9 minus 2 times 180 to get our sum and divide it by 9. The number of sides is also the number of angles in a polygon. So we get 7 times 180 divided by 9. I can simplify here. 9 goes to 18 twice, add the 0 for 20. 7 times 20 is 140. All right, let's look here at the next example, example 3. What is the measure of angle Y in pentagon today? So if you look at this right here, it's pentagon. That means it's got 5 sides. Well, we're 4 angles given. That means we're missing 1 angle. So like we did in a triangle, if I gave you 2 angles of a triangle, you'd add them together and subtract from 180. So in this case, we're going to add these together and subtract from another number, but it's not going to be 180. So we need to know what is the sum of these angles. What should it be? So if n is equal to 5, then we're going to do 5 minus 2 times 180. 3 times 180 is 540. That means that all of these angles should add up to equal 540. So let's set them up. We have 110 plus 90 plus 120 plus 150 plus angle Y is equal to 540. Add them all up. That gives us 200. 110 and 90 gives us 200. And then 200 plus 120 gives us 320. 320 plus 150 will give us 470. So 470 plus Y is equal to 540. So now we subtract 470 from both sides. And that gives us that Y is equal to 70. So 70 degrees is our answer for Y. So depending on the shape, you're going to add them up, find the sum, and you're going to add these angles up and set them equal to that. All right, so let's have you guys look at part B. Find the measure of angle G in quadrilateral EFGH. Pause the video, come back and check your answer when you're done. All right, we have 4 sides. That sum is going to be 360. Add your angles up. 120 plus 85 plus 53 plus angle G is equal to 360. That adds up to be 258 plus angle G equals 360. Subtract 258. That's going to give us that angle G is 102. You can always double check by adding it up and making sure that it equals 360 degrees. All right, let's take a look at this. I want you to find the values for x and y. Remember that this is an exterior angle, and so these two together form a linear pair. So find the values of x and y, pause your video, come back and check your answer when you're done. All right, so once again we said that these are a linear pair, so you're going to subtract 110 from 180 and get 70. That adds to our total, so we add these up. 70 plus 112 plus y plus 88 equals 360. Add these up, subtract from 360 to get 90 degrees. So y is a 90-degree angle. Now, you can form an exterior angle of any polygon by extending each side so that each exterior angle forms a linear pair with the adjacent vertex. So if you look at these, if we added all these up, if we added up 80 plus 130 plus 150, you're going to get 360 degrees. If we added up 115 plus 75 plus 99 plus 71, it's also going to equal 360 degrees. So this tells us that any angle, all the exterior angles of any polygon not regular, doesn't have to be regular, it can be regular, will always add up to 360. And the reason for this, and I'll kind of give you a good example of this, if I took these two lines, now that what we've done, these are extended to make exterior angles, and the first one doesn't have to move because I'm going to move everything to one vertex. So one of these will stay in its place. I'll just leave this one here. So we're going to move everything to this point here. So if I took this problem here and I moved it up here, notice I have not changed this angle measure from this line here to this here. Is still the same 130 degrees. If I were to take this set line and move it up here, put the vertex in the same spot, I have also not changed this angle of 150, which means this angle right here is going to be 150. And since this one doesn't have to move from this side to this side, this is also 80. So if you add these up, they give you 360. Forms a circle. Circles have 360. We can do the same thing over here. Everything would come together at one vertex, and it would also form a circle, 360 degrees. So let's look at the polygon exterior angle sum theorem. The sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. So all these angles will add up to become 360. So let's take a look at finding one of these angles in an exterior angle in a regular polygon. Now, this only works, what I'm about to show you is only going to work for a regular polygon, which means all the sides are the same and all the interior angles are the same. But if all the interior angles are the same, then the exterior angles should also be the same. So, to find your exterior angle in a regular polygon, you're going to take, I'll make this angle measure, you're going to take 360 and divide it by the number of sides, n. So in this case, to get our exterior angle, we're going to take 360 and divide it by 8. So our exterior angle would be 45 degrees. So that means angle 8 is 45. Angle 1 is 45. 2 and so forth and so forth. Now these are the exterior angles that they have to form a linear pair with that interior angle. So this one here and this one here are going to form a linear pair. These two form a linear pair. So if I know my exterior angle is 45, what would be my interior angle? Well, you just take 180 minus 45, and that's going to give us 135. So this angle is 135. And because it's a regular polygon, all these are 135. And each exterior angle is also 45. So this is a shortcut that you could use to actually define the measure of each interior angle of a regular polygon. Find the exterior angle by dividing it by the number of sides by 360 by the number of sides, and then subtract from 180 to find your interior angle. All right, so take a look at the next one. What is the measure of an exterior angle of a regular nonagon? Pause your video. So the exterior angle can be found by taking 360 divided by 9, the nonagon. That gives us 40 degrees. So if I drew just part of this polygon here and I extended this line here, this is your exterior angle. This would be 40 degrees. So what would your interior angle be? Well, they have to add up to 180. That would be 140. 40 and 40 give us 80. All right. In this example here, you're going to come across a few of these. They're giving you the exterior angle. So they want you to find the interior angle and the number of sides. So the easiest way to work this is to take, first of all, to find your interior angle, you're going to find two parts, interior angle, and you're going to find your number of sides, or your in. So the interior angle can be found by taking 180 minus 36, and that gives us 144 for the measure of each interior angle of this regular polygon. Once again, it's regular. They say it up here. This would not work if it wasn't. Now, for the number of sides, what we have to do is we have to figure out how many 36-degree angles will go into 360. So we take 360 and divide it by 36. Calculate that out, and that comes up to be 10. That means there are 10 sides in this polygon that has an exterior angle of 36. So before we said the exterior angle was equal to 360 divided by n, if I was to solve for n here, I'd put n multiplied by n. That leaves me with n times the exterior angle equals 360. And if I need to solve for n, I just divide by my exterior angle, both sides. That leaves us with n equal to 360 divided by the exterior angle. So at 72, let's find our interior angle. We should remember again, it's going to be 180 minus 72, which is going to give us 108. Number of sides, that's going to be 360 divided by 72. They'll always come out to be even because you cannot have a half a side. And when you divide this out, you get 5. So this is a 5-sided object. It's a pentagon. Each interior angle is 108, and each exterior angle is 72. All right, so now I want you to take a look at this and find the values of x, y, and z, and w. So use what we talked about today. Pause your video and come back and check your answer when you're done. All right, so we have all of our letters we have to find. The first one we can find is letter z, because all of our exterior angles add up to be 360. The x and the y and the w we can't find yet. We have to know what these outside angles are first. So we set them up, add them up to equal 360, solve to get 121. When you go back and plug it in, you're going to get 108 for this angle, 121 for this angle, and 131 for this angle. So to find w, we're going to take 180, because it's a linear pair, it's our exterior angle, 180 minus 108. That's going to give us 72 degrees. Now x is a linear pair with z. So if this is 121, this will be 180 minus 121. That's going to give us 59. Then we have y. Y is right over here. This is 131. So 180 minus 131. That's going to give us 49. And the last one we already found was z. So these are our answers for w, x, y, and z. Now this concludes lesson 6.1. Anything you missed, you can go back and check it out.